All right. Hello, everybody. Welcome to our Advanced LWC Best Practices talk. It's really nice to see you here, for those of you who are here in person, so early in the morning. We have a bunch of content for you, so we're going to jump right into it. But before we start, safe harbor slide. I'm sure most of you are familiar with this by now. But as Salesforce is a publicly traded company, don't base your purchasing decisions on products and services that aren't available yet. We might have some forward-looking statements in here, although for the most part, we'll be focusing on features that currently exist. But at the same time, disclaimer here. First off, just thank you. Thank you for coming. Thank you for attending this talk. Thank you for the ways that you engage with the Lightning Web Components and with the community. Your feedback is extremely valuable, and we look forward to being able to continue to make LWC better and better as we hear from you and as we work together in this ecosystem. Introduce myself. My name is Jason. I am a lead on the LWC team. We work primarily with the Lightning Web Components core framework. So the runtime that works on the client side, the compiler, and then a bunch of various tooling and ecosystem kind of close to core LWC.
Yeah, and I'm Bhargav. I work on the Lightning-based components team, and we typically build the out-of-the-box Lightning components that you find in the component library.
All right, so here's what we're going to cover this morning. We're going to jump into some general performance tips and tricks. We're going to talk about native shadow, some CSS best practices, and then we'll end off with a collection of various LWC features and best practices that might be useful to you. Overall, this talk will just have a collection of various concepts, so we might be jumping around a bit. And because this is called an advanced talk, we're going to assume some base level of web components experience, LWC experience, web development experience. We're not going to be talking a lot about features that are coming soon, so if you are interested in that, please do go check out some of the other amazing talks or demos that are being showed here. And with that, I'll let Bhargav kind of take us off into performance.
Thanks, Jason. All right, we have a few topics under the performance section for you, but let's start off with something simple to get warmed up, right? Doing the cheap check first. This is pretty straightforward, not really much of an eye-opener, I'm sure. But you'll be surprised how often you might find this in your code base or how often this gets overlooked during code reviews. The idea here is if you're evaluating in a condition multiple variables or expressions, you want to be cognizant of which ones are more of an expensive operation over the others. So in our example here, we have an if condition which is evaluating two things. Computed show element, which is, for argument's sake, let's say is a complex operation, and is disabled, which is a simple Boolean variable. In our example here, we want to do our cheap check first, which means we want to evaluate our Boolean first. That way, if it fails, we can fail fast, and we can avoid having to do the complex check altogether, right? Easy. Moving on to our next topic, which is plucking or caching. This is an interesting case. Consider a scenario where you have a getter which performs expensive operations, right? In our example, we have a getter for an anchor, which has an if condition evaluating three things. It evaluates two Boolean variables, is connected and is disabled. And then it also evaluates should display link, which again, for our argument's sake, let's say is an expensive operation. If this evaluates to true, it still goes ahead and performs another expensive operation in the form of a DOM query. Now we have this getter which is expensive to run. And that's fine. Sometimes that's unavoidable and it's okay. But how do we use this getter in such a way that you don't incur any unnecessary performance costs? If you do what's on the left-hand side here, the getter will run twice. It'll run once when you do if this.anchor, and once again when it does this.anchor.click. If you do what's on the right-hand side, it's going to run the getter only once. It'll run it once on the first line where we pluck anchor out of the current object, and then use that value in subsequent operations. In general, if you're not sure if it's an expensive getter or not, this is a good practice to just follow because you're going to have to run your getter once in any case. All right, hope you're all warmed up now. Let's delve into some deeper topics. I want to talk about trade-offs, specifically about composition of your components versus flattening the structure of your components. To compose or not to compose, that is a question. You would have heard or read in blog posts or articles saying that make your components modular and make it do one thing well, and compose them to create larger and richer experiences. Well, that's fine for the general case. Think about how that might relate to your specific use case. If your component has heavy logic or is rendering a lot of elements on the page, think about the pros and cons of both of these approaches before you decide on an approach. Since composition is the recommended pattern, that's what we would go with by default. But let's take a look at an example where flattening the structure might actually be more beneficial. On the left-hand side here, we have a custom component, which in turn renders other custom components, right? We have custom foo, bar, and we have a for each directive which repeatedly renders the baz component, like a list item. And on the right-hand side is the implementation of this baz component. This one's got heavy logic inside it, let's say, that evaluates, and depending on the result of that logic, it'll render some other custom components underneath that. Now, this code might be very well structured. It might be very well organized, no doubt about that. But if this component has heavy usage in the app, especially if it's rendering hundreds or maybe even thousands of these items, these list items, you may have a situation where the performance of your component and even your application gets degraded. So what do we want to do in this situation? Think about the flip side also. If you have a component which is rendering, let's say on average, 500 list items, if you're able to remove maybe one element or even two of those elements from that list item that you're repeatedly rendering, you might end up with 500 to maybe even 1,000 less elements on the screen. And extra points if you're able to remove custom LWC components from that repeated rendering too, because you get to skip the overhead of creating that custom component, attaching it to the DOM. So how do we do that? What we might want to do in that case is to move the logic from some of the lower level components back into its parent. And when you do that, the parent has the ability now to render as many elements inline as possible. And you can skip those extra custom LWC components as well. That'll give you a bigger perf gain. That ties really well into the topic that Jason will speak about next.
All right, so as Bhargav kind of shared, part of the idea of web components and composing web components is that we're able to build small pieces of the UI, have those small pieces kind of focus on doing something really well, and then we can use it across the board in different places. We can expand that to allow for more modular and more complex components. You know, we take those small, simple components, we compose them into larger experiences, cards, different pieces of the UI. And oftentimes when we start doing this, we also want to add a lot more functionality. So we might start building out components in components. We might have a component that can take in just a record object or some other object from third-party data, and it'll know, given a bunch of other metadata objects, exactly how to display the UI for you, and we just put it on the page. We deliver that, it works out really well, and that's great. And then we start reusing all over the place, right? And someone or we decide, hey, you know, it'd be nice to be able to have a large list of these items or a large collection of these. So we start building out, and our application gets more and more complex and more complex. This usually is the start of when we start hitting some performance issues, and we need to start looking into it. During this time, I kind of want to point out, as we kind of build that out, sometimes then we need to go back and reconsider just the pattern that we've been using. One thing to keep in mind is that web components and LWC, everything has overhead. right? We add more elements onto the page. And if it's a static page, generally the browser can handle it. Once we start adding interactivity, every single new element can start adding performance implications. We add functions, and that messes, or not messes, but it adds to the heap for every component. Event handlers also add to that. And if we're suddenly deciding we want to reuse large pieces of complex components, and we start hitting performance issues, maybe then it's time to go back and think, hey, are there ways to simplify how much we're reusing? Two common things that we've seen a lot is oftentimes we might have these heavy components and we'll start reusing them, and we basically end up having this overhead from these little pieces being duplicated over and over, and it becomes a multiplicative performance overhead. We might have expensive operations in those components that made a lot of sense when we designed them to be self-enclosed experiences. But now that we're scaling it up, those expensive operations are suddenly, they might be unnecessary. And so the goal here is there isn't necessarily a straight do this, but consider, do you actually need to do all of that? Is this component you're reusing actually the correct one for your use case? Or is it potentially time to refactor? Or is it potentially time to build a new component that can handle the performance needs of what you're building? The first section is the unnecessary or unexpected overhead. Components have overhead. There's reactivity for all these components, which is great when you need it. But if you have very simple components sometimes, you don't necessarily need a ton of reactivity. If you're building out a component with a lot of flexibility in the properties that it's able to receive, you're also introducing reactivity around those principles, or those properties. That can add up. You might have extra DOM elements. You might have components in there that you've built to be very flexible with the layout that it can generate. So it has all sorts of things, and then when it takes in objects, it'll decide what to fill them in. You might have event listeners that'll handle different use cases. And again, all of that might make sense in smaller use cases when you're building it out. But when you start scaling it up, sometimes you end up with elements that might not be needed in this larger scale application that you have. The example here looks straightforward, div, 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 but maybe it's coming from 3 different custom elements. The top one, it figured out, OK, I need to render this component, and it renders that component under an empty div. The other ones do all that stuff. But when you look at it on the page, there's 3 divs here that may or may not actually be needed, wrapping the actual content that you need. You scale that up to 500 of them, 5,000 of them, depending on what you're trying to build, and removing a single div, that's like 1,000 elements on your page that you don't need anymore. I think the recommendation for a fast working page is about, honestly, under 2,000 elements, and I'm pretty sure most applications out there on the web are definitely way more than 2,000. That might be fine if you're working with static pages. If you're adding a lot of interactivity, then this is one area to consider then when you're working with these large scales. Do you actually need all of these elements? Do you actually need all of these event handlers? Or is it potentially time to refactor, to split things up into different templates, to maybe introduce these containers dynamically so that in the use case of you just need the content and you don't need this event handler, and this styling isn't applicable for your use case, you're not displaying all the extra divs in that part, and you're able to kind of remove all of that overhead. The second part is expensive operations. I think this is a common pattern that we've seen sometimes when we pass in an object from another component down. Sometimes we want to mutate it, and so a common pattern I think I've seen and we've seen is a lot of times we'll just deep copy the object and then make our adjustments there, and then we'll continue on with whatever the component does. It might go on to other components. Again, this might be fine if your component is only used 10 times on the page, 20 times. Modern browsers can be pretty fast. You scale this up to like 1,000 times, and now you actually do have a performance problem. The question here is really, do you need to be doing this at the leaf nodes of your components? Do you need to be processing all of these records at the level that you're processing at? Or is it potentially possible to move that logic higher up and split it up? So instead of passing large objects and having a lot more processing happening lower on the component tree, you can move all of that higher up and have it done way fewer times. This is similar to the concept that Bhargav mentioned earlier about plugging and caching. Do the heavy operations as little as possible and pass the data down and let the components that are used more frequently do less so that they can be faster. The other one that's often commonly overlooked is forced re-rendering and other DOM manipulations. Manipulating DOM can be heavy, can be expensive. Sometimes we forget that, and at our leaf notes, we're accessing the DOM, doing query selectors. Again, that might be fine in a lot of use cases. When we're scaling it up to more high-performance use cases, all of that can add up. If we're mutating properties on components, keep in mind that for some of these components, they might be reactive to those changes. So if we're updating this property and then we're updating another property, we're updating another property, are there ways to simplify that so we're not causing a lot of unnecessary re-rendering, and at the same time, we don't need to be kind of thinking about all of this as we're kind of trying to grapple with what the component tree looks like. Because sometimes when we're building those small reusable components, we think, okay, that's fine. We'll update this property, it'll re-render, and that's great. We update this property, we want it to re-render. But then for example, the common thought, can I update both properties and I don't want it to re-render until both have been updated? But I may or may not have both properties at the same time. That's kind of a more complex question there. And although in smaller use cases, it may not be necessary to optimize for this. If you're scaling again to like hundreds or thousands, having those extra re-renders can be an overhead that you might be able to cut out if you designed your component to support kind of that atomic property update and have it only re-render once instead of multiple times. And so considerations for this. First of all is, one, don't optimize unnecessarily. As we're thinking about these, we should tailor our designs towards the use cases that we know we're trying to build for. If you already know it's a high performance use case or you're already dealing with performance issues, then it may be time to go and look at this, to be time to refactor and everything. If you're just starting out, a lot of these considerations, they may not necessarily be necessary. They might be adding a lot of extra overhead, and you might be overcomplicating things, making things more complicated, and that can introduce a lot of extra bugs. So really the top one is think about your use case. Afterwards, consider, do you have expensive operations lower on the component tree that you may be able to consolidate and refactor upwards? All right, so let me see, expensive things higher up. If you're able to move those pieces higher up on the component tree, then they get performed less often, and you don't have to worry about all of that overhead. The third one that I have is try to reduce the number of responsibilities a component might have. You might have a component that tries to do a lot and is able to work really well within the context of give it a record, give it an object, it'll do and figure out almost everything. However, when you start using that in multiple places, do we actually need it to do all of that? Or can we, again, move those responsibilities higher up so that they can be used in, so that you don't have to duplicate all of the new features? Something I need to do here? I think we need to.
How's your power?
It's fine. It's pretty high. All right. Thank you. Reduce unnecessary rendering and re-rendering. This one might be a little trickier, but double check to see, do you need to be re-rendering everything that you're rendering, or are you able to cut back on that? Avoid or consolidate unnecessary DOM elements. Look at the end product of what's being displayed and kind of double check, hey, do I need all of these elements? And then finally, just kind of repeat of before, understand your use cases and trade-offs. Sometimes as you're building out components, like for modularity and composition, that works out really well for those use cases. But for high performance use cases, you might need to rebuild those, refactor those, consider the high performance use case. Don't just treat reusability as something that you can just take and use every single place. OK, here's a tool that we have that's related to the topic I mentioned earlier about rendering. So I don't know if you know this, but in the performance tab of the Chrome DevTools, we actually do ship timings for the life cycle of the various components. So here, what you can see is a custom element running in the Salesforce Lightning experience. And we have a bunch of performance tags for the underlying infrastructure. But we'll also have the custom component here. Here you can take a look at how long it's spending in the various lifecycle methods. And based on this, then, that can help narrow down, if you're at debugging, where in the actual JavaScript stack you need to be looking if you're trying to debug performance. It's a way to quickly kind of narrow down what you're trying to look for. This is coming soon. This actually just got merged, I want to say, last week into the LWC OSS repository. But Chrome DevTools exposed some of their extension APIs in August. So we are now able to enhance the tooling that we're providing for you as you're looking into performance-related things. A few things to call out. We're not in the timings section of the DevTools. We're actually in a custom track, if you look on the far left, called Lightning Web Components. So this is being separated out from the other timings that might be on the page. The other thing to call out here is you can see there's a lot more detail that we're being able to provide. There's a mouse over detail telling you, in that blue box, this is the component, and this is the life cycle that it's actually running. More details about just the hydration or rehydration. So with this, you can have a better idea of this is what's happening with my components. Is there anything that's unexpected? And then finally, on the bottom, you'll see in the details section, there are more details we're able to provide now. So this just got merged last week, which means that it probably won't be able to make it into Lightning Experience until spring 25. However, if you are working with LWC OSS and you want to kind of try it out, it's there. You can try it out, and we love to hear feedback or anything about it that you think you'd like to let us know. All right, so moving on. Our next section is going to be native shadow. I'm going to go through a quick refresher, and then Bhargav will take us away with some tips on working in a native shadow environment. Just a quick refresher, native shadow is a feature in the DOM that allows you to encapsulate your web components, allows you to encapsulate the styling, the JavaScript, the various properties of it, and kind of keep them enclosed. It allows you to protect them from external influences and allows you to choose which parts of the component you expose externally so that external factors don't necessarily take dependencies on what's inside your component. For those of you who are less familiar with this, like previously for native HTML elements, you might have inputs and buttons. This is similar to that concept, and there's more going on inside the input and inside the button, but it's not exposed to us. Only certain attributes and properties are exposed to us. So one benefit here is we currently in Salesforce have something called synthetic shadow. It was originally built for IE11. It polyfills a large part of shadow. However, it's only partial. It doesn't support some of the features. And it's slower because it's our code running on top of the browser versus just the browser handling it. With native shadow, all the browsers now support it. So if you move onto it, there's less of that overhead from our synthetic shadow code. There are more features with it, especially part slotted, SSR, et cetera. And some of those can be very helpful for working with native shadow components. And then there's no more need for LWC DOM manual. The other aspect of this, yes. And so to enable it, just add this to your component, and you can opt your component into working in native shadow. All of its child components will also be opted in, so that's something to keep in mind, in that native shadow applies to the component and everything underneath it. All right, Bhargav's going to go in and tell us more about working in a native shadow environment.
Thank you, Jason. Excuse me. All right, let's talk about how you can structure your templates in such a way that will allow for effective customization in the native shadow DOM environment. The part attribute is your friend here. Think of the parts as the bones of your component, something that gives shape to your component, something on which you can add more structure and more styling. The part attribute enables customization by allowing CSS to select and style specific elements within your shadow tree. So it'll allow components outside of it to style elements inside of its shadow tree. So because it does this, be careful and be selective about what elements you set the part attribute on, because in a way, it gets exposed externally from the component and becomes part of the API of your component. Let's take a look at how we can do this. So let's say we're building this custom button where the user can pass in a button label, and then they can pass in a start icon and an end icon. On the right-hand side is the implementation of what that might look like. Now let's break this down into different pieces and see which of those pieces we want to allow customizations on. So just visually, we can tell that there are 3 different pieces or parts to this component. We have the outer larger button container, and then we have the 2 icons, which are the 3 different pieces. Now let's see if we want to allow customizations on all of them, going one by one. For the outer button container, we might want to allow the users to, say, change the background color of this button, or change the font color, or change the font size. Similarly, for the icons, we might want to allow the users to, again, change the background color, maybe change the border color or the border width, or maybe even change the size of the icon. So we've identified that this custom button has 3 pieces, and we want to allow customizations for all 3 pieces in native Shadow DOM. How do we do that? We set the part attributes on those elements. So for the outer container, we set part equals button on the button element, and then we set part equals start and part equals end for the 2 icons. Now that we've set these attributes, CSS can now select and style these elements from outside. And we'll see shortly how that's done right at the end of our next topic, which is state reflection. All right, so state reflection is another practice that we think is best practice, especially when you're migrating your components to work in the native Shadow DOM environment. It's based on the principle that your component should typically provide some sort of visual feedback when the user interacts with it. So if the user clicks on it, hovers over it, focuses it, or if the component goes into some sort of an error state, typically you want your component to provide visual feedback. How do we represent this in our HTML? We'd set these attributes onto the host element of your custom component. And then you would utilize these attributes for styling, along with the part attribute that we saw earlier. Again, let's take a look at an example. Let's say we're building that custom button again. And let's say this button now has a few variants that we want to style differently. Let's say it has a brand variant, which gives it that blue background button color, a success variant, which is a green button, a destructive variant, which is a red colored button. And let's say that we want to show something different when the user focuses on the button as well. How do we do this? So if you take a look on the left-hand side, the setter for variant is setting the variant attribute and the value that's passed in onto the host element by using this .set attribute. So we're reflecting the attribute onto the host. Similarly, on the focus handler, we're setting the focus attribute onto the host by using this .set attribute. So in a way, we're reflecting the state of this component back onto the host. On the right-hand side is what the rendered DOM would look like. So you have your custom button, which is C button, and then the variant equals brand, or whatever, success or destructive, and you have focus as well being set on the host element. Now you'd use these attribute selectors along with the part attribute to style your component. Let's take a look at the example for that. So let's say in our first case, we are trying to just style the button, the brand variant button. How would you do that? You'd select the host along with the attribute you want. So we're selecting variant equals brand. And then you target the button element through the part equals button. And then you set the CSS property for that. Similarly, for the focus state of the brand variant button, we're selecting the host, select the variant equals brand and focus attributes together, and then you target the part equals button attribute, and then change the CSS for that. So yeah, that's how you would style your components in Native Shadow. All right, so that wraps up our Native Shadow section. Native Shadow is relatively new, so hopefully you'll find some useful tips for you to take away when you migrate your components. But that ties really well into our next topic, which is CSS best practices. And styling hooks is first up. If you haven't heard of styling hooks yet, styling hooks are basically a way for you to customize the look and feel of your components so that you can express your brand visually, appropriately. These are extremely useful when you're using them with Lightning-based components. There are two types of styling hooks: component-level styling hooks and global styling hooks. And the name is pretty self-explanatory here. Component-level ones are scoped only to your component, while the global styling hooks are values that permeate throughout the entirety of your application. Again, let's take a look at an example. Let's say that we're building a custom button again, and we're utilizing the Lightning Design System's blueprint for button. This is what it'll look like. So you have your button element, which sets two classes on it, SLDS button and SLDS button brand. Now this gives it that Salesforce look and feel. It gives you that blue background button. But blue's not really your color. So let's say you want to make it purple. How do you do that? Well, let's talk about what you don't want to do first. You don't want to target the SLDS classes and override the styles for that. And the reason you don't want to do that is because SLDS classes work in tandem with other SLDS classes. So if you're overriding the styles for one, you might end up with unexpected behavior elsewhere. Instead, what you want to do is use the styling hooks that are relevant for this blueprint and use that for styling your component as needed. How do you do that? On the right-hand side, you can select the host because you're scoping your changes to your component, and then you would use your styling hooks underneath. So here, since we're implementing the button blueprint, and we're changing the brand variant, and we want to change the background color or the border color, we're using those appropriate styling hooks to change the colors. The naming convention for these styling hooks are pretty intuitive. You should even be able to eyeball them and see which one applies to your case. But let's see where you might be able to find them. This is the Lightning Design System website. It has a bunch of design patterns and component blueprints. The one that we were just talking about now is a blueprint for button. So this is the one for button. On the right-hand nav, if you take a look at the bottom, there's a link to styling hooks overview. So if you click on that, it'll take you to a section which lists all the styling hooks that are relevant for this specific blueprint. Similarly, if you're using a Lightning-based component that implements this blueprint, you should be also able to use the styling hooks to style those as well. All right, so this is just one small example of what's possible. On the left-hand side is probably something that's very familiar to all of you. It's the activity composer that typically sits to the right-hand side of your record homepage. So we've taken that and completely transformed it to what you see on the right-hand side here using only component-level styling hooks. So you can see this is a pretty powerful tool if you want to align your product to your brand with very minimal effort. All right, next up is CSS combinators. Combinators are basically some things that describe the relationship between selectors. Combinators typically make CSS fragile, so it should be avoided unless you have a really good reason to use them. And typically, you should be also able to remove CSS combinators from your code without regression. So I urge you, when you go back and you find combinators in your CSS, try removing them and seeing if things still work. You would have instantly made your component more robust. So let's talk about some don'ts that are related to this. Don't rely on the DOM structure. Combinators force you to do that, but don't rely on the DOM structure. Don't rely on it, especially if you don't own the internals of that component. And this extends to Lightning-based components as well. Since you don't own the internals of the Lightning-based components, you have no control whether the markup underneath changes or not. So if it does change, your customizations will be broken. And the DOM structure underneath can actually change for very legitimate reasons. There might be a new accessibility standard that comes out that requires a DOM change. There might be performance optimizations. There might be a bug fix, or maybe even a new feature that requires a DOM change. And all of these can just instantly break your component. Another thing we don't want to do that we just spoke about in the styling hook section is to target SLDS classes, because that will lead to unexpected behavior. Instead, what you want to do is to target classes or parts or attribute selectors, because even if the DOM structure does change, those classes or parts or attribute selectors are still likely to remain in that markup. But even better if you're able to use styling hooks, because this is our supported API. All right, that wraps up the CSS section. Jason and I will talk about general best practices in our final section here. I'll start us off with some design considerations and hand it off to Jason to speak about some more optimizations and another tool you might find useful. All right, aligning with the web platform. This is something we strive to do at Salesforce on a daily basis, but we encourage our customers to also do the same, especially when thinking about design patterns. When you use industry standards, your code instantly becomes more intuitive, more readable, more accepted by the developer community, and generally promotes adoption. But this is an extremely broad topic, and I really want to focus specifically on the usage of slots versus attributes when you're attempting to display content or data or visual elements. So let's talk about that. Typically, you might want to use attributes when you're trying to give a way to configure your component or pass data into your component. So if you want to, let's say, allow the user to change the variant of your component, right? You'd use that through an attribute. Or if you want them to pass data into your component, you'd do it through an attribute. If you want to have them display some sort of content, like let's say icons or buttons, you typically might want to let them do it through slots. Let's take a look at an example again. So we now are building a custom button group component. And this button group has 3 buttons, the first one being one with the label download and an icon to the right-hand side. The middle one being just a regular button with the label edit. And the third one is a special type. It's a button with only an icon, but when the user clicks on the button, we want to show a pop-up menu with a few menu items, right? And you are now hit with the question, what should the API of this component be? How do we want our customers or users to pass in data into this, pass in the buttons to your component? And the 2 options that we spoke about come to mind. We have slots or attributes. Let's look at attributes first. In the code snippet in the bottom is how it would look if you used attributes. So you have your C button group component and then your attribute named config. Now this config has you asking your users to pass in all the data and metadata required for you to render each of these buttons. Let's take a look at what that will look like. So config here would be an array of objects where each object contains the metadata for a single button. So the first one has a label for download, the icon you want to display, the position of the icon. Second one just has a label edit. And the third one, because it's a special type, we need to specify that for any special considerations, saying type equals button menu and then icon name. And now in the bottom, you can see that we have items, which is basically something that you need to now accept as metadata for the menu items. You can see where I'm going here with this. This is a button group component, and we're having to support APIs for menu items. The more buttons and different types of API these buttons support, the more you will have to support in this object. So it ends up becoming large and complex. And also, if you notice, the name of this attribute is config. The only other thing that might make sense is metadata, which is a generic catch-all term for the users to pass in anything under the sun. And that's not really good optimal design. This is what it looked like if you use slots. So you have your custom button component, and then your users would pass in their buttons within that. Just looking at this, it's a lot more intuitive. By reading it, you kind of know what's going on here. And let's say you have these new buttons that are getting added. When we did it via attributes, you'd have to support the APIs for each of these buttons. If you have like 5 new buttons, you have to support the APIs for all of those 5 buttons. But here, you wouldn't have to do that. You might have to make accommodations to make those buttons work together within CSS or some other way. But you wouldn't have to worry about what that button has as an API. You don't need to worry about the menu item. when you're trying to make a button group. So why are we even having this conversation at all, right? Why the slots seem to be the obvious answer. Why are we even talking about this? Well, it turns out that attributes also have certain benefits. The first one being control over the reliability of your component. You control exactly what gets rendered within that component. So if the user is passing in nonsensical things, you can ignore it easily and you can make sure you're rendering the right things and your component always works the way you expect it to work. Typically, this is also possible with slots. It's a lot easier with attributes. The second point is actually the most important one, where since now you have the attribute which contains the metadata for each of those buttons you need to render, you can typically render these elements in line. And this ties back into that previous topic of reusability costs. Now you can render these elements in line and avoid having to render custom LWC components. So think about that when you're designing your components. In the general use case, the benefits of slots outweighs that of using attributes for the general case. But it's definitely worth a thought. And I'll let Jason talk about template refs.
All right. So we know query selectors can be expensive. They're often the known way of accessing elements in the DOM. LWC, however, does support something called template refs. Basically, in your template, you can tag an element or a custom element, which include LWCs, with LWC:ref and give it a name. Inside your component, you can then refer to that element or web component just using this.refs, whatever you named it. This value will stay undefined until the reference is actually rendered. So you can also use this as a quick check to see, hey, is this rendered or not? And that is actually one of the recommended ways of working with dynamic components, where you're importing a constructor or a component definition dynamically, and you want to know when it's rendered. The guarantee is that at the next rendered callback in the lifecycle, after it's rendered, the reference to that will be defined. So if it's undefined, it hasn't come in yet. The other thing is it's definitely relatively faster. What LWC does under the hood is it grabs that reference during its rehydration while it's actually rendering. So it doesn't actually go to the DOM to get that element. It grabs it before it's even appended to the DOM. So you get that reference without actually having to touch the DOM. This is just a really quick kind of benchmark with it. For this.refs, it can do 9.5 million ops versus query selectors 175K ops, so order of magnitude higher. This is a minor change because I don't expect most of your use cases are going to involve 10,000 iterations of query selector happening all at once. But in case you are working with high performance applications, it's something good to know, and it's a good practice, use template refs instead of query selectors if and when you can. Next thing, native object rest spread. So before in Winter 24, we would use Babel to polyfill the ... syntax for the JavaScript in your components. That was to support IE11. On the left, that's the polyfill. On the right, in Spring 24, because we no longer support IE11, we're able to remove all of that code out of the component, and so you actually just get the ... and the browsers will take care of it. This is great. This is like 98% less code here. If you're using it in a lot of places, like this can be a really great improvement just to the heap size of your component and how much code the browser needs to load. The problem is there are slight differences in how the Babel polyfill operated compared to the native behavior. And so actually just removing it for everyone would be a breaking change for some components in some edge cases. So we couldn't do that. So unfortunately, in order to take advantage of this quick optimization, you do need to update your component to API version 60 to take advantage of that. Next thing, encapsulate composed events. The best practice here is just be intentional about your events, especially with native shadow DOM. An event with composed true will escape this shadow boundary. And the best practice here is be intentional about what you allow to escape your shadow boundary. Treat your events like part of your component API. If you don't need it outside, keep composed false. If you do, keep it true, but consider stopping propagation at a higher level so it doesn't kind of leak out and go somewhere you don't want it to go. Again, be intentional about eventing in your components. Treat it like part of the API. Finally, we have a useful tool. I don't know if you know this, but Chrome DevTools also allows for custom formatters. I don't know if you've ever tried debugging objects in a Lightning experience and you hit up with a proxy object and you're kind of like, what is this? And you have to unwrap it to even look at it. We actually do have a custom formatter that's shipped in Lex if you're in debug mode. And what happens is it will unwrap it for you visually, so when you're mousing over an object or you're kind of trying to see it in the console, you will see the object itself instead of the proxy. You can get it just by opening up your Chrome Tools dev setting and finding enable custom formatters under preferences. This comes automatically with Lex. It doesn't change the JavaScript itself. This is just a visual thing to help you as you debug. You still do have to dereference it using the actual original structure, and the objects will still read only. You can't manipulate it. All right, quick resources, and Bhargav will close us out.
Thanks, Jason. Yeah, we have some resources for you. Please take a picture of this. This will lead, it's a link to a Trailblazer community post, which has a bunch of documents, including this slide deck. So please take a picture. I'll give it a few seconds. All right. And yeah, thank you all for taking the time to attend this session. We hope you learned something today and are able to take away some important tips that you can use today. Please provide feedback. I think you probably would have already seen this, but instructions are there, QR codes there. Your feedback is extremely valuable to us. So yeah, please do that. If you need extra motivation, first 4,000 attendees get $5 Starbucks gift card. And finally, the Einstein session summary for this event will be available soon. It'll be a recap of our talk today, and you should be able to find it later today in the Salesforce events mobile app. So look out for that, and thank you all once again.